Hi everyone, I'm going to discuss linear inequality in two variables. Last time you learned about graphing linear equations in two variables. So this time, graphing linear inequality in two variables would be easier for you since one of the requirements in sketching the graph of a linear inequality in two variables is your knowledge on how to sketch the graph of linear equations in two variables. When writing an equation, we use an equation symbol or an equality symbol to indicate that two algebraic expressions have the same values. Now, in this lesson, we're going to use an inequality symbol to indicate that two algebraic expressions do not have the same values. And we call this relation as inequality. Now, class, the definition of a linear inequality in two variables is closely similar to the definition of a linear equation in two variables. Now, a linear inequality in two variables is any expression that can be written in the form ax plus by is less than c, where a, b, and c are real numbers. So the definition can also be stated using the other symbols for inequalities like less than or equal to, greater than or equal to, less than, or greater than. Now, you encounter the phrase at least, and this is associated with greater than or equal to. For instance, one statement like your grade for you not to be transferred to another school is at least 80. So meaning your grade should be equal to 80 or greater than 80. So that's the idea of the phrase at least. On the other hand, you encounter the phrase at most. So this is equivalent to the inequality symbol less than or equal to. So for example, for you not to be for you not to be dropped in this school year, you should incur at most 10 absences. So meaning you should only incur maximum of 10 absences. So less than or equal to 10 absences. Now, the following are some examples of linear inequalities and their standard forms. So this is slope intercept form. So we have 2x minus 3y is less than 1. When converted to standard form, we have this one and this one. So as what I was saying, linear equation is closely related to inequalities. Remember, we also have the standard form of linear equation. We also have the slope-intercept form of linear equation. Now, verifying the solutions of an inequality. So the solution of a linear inequality in two variables class is a pair of numbers xy that makes the inequality true. So meaning we're going to substitute that point to the inequality, and if we come up with a true statement, then that point will be one of the solutions. The solution set is a set of all solutions of the inequality. So the graph of the solution set of an equality is a region determined by all the solutions of the inequality. Now, in each of these points, we're going to identify which among the points here is a solution of this inequality. So, as stated, we're going to substitute the point to the inequality. So, we have to substitute negative 3 to y. So, we have negative 3 is less than or equal to 4 times the value of x, which is 0, minus 3. Simplifying, we have negative 3 is less than or equal to, so this is 0 minus 3, so we have negative 3. Since negative 3 class is equal to negative 3, then we can say that this is a true statement, and we can conclude that 0 negative 3 is a solution. For number 2, we're going to substitute 1 and 2 to the x and y of this inequality. So we have 2 is less than 4 times 1 minus 3. So this is 2 is less than 4 minus 3 is 4 minus 3 is 1. Okay? So 2 is less than or equal to 1. This is a false statement. So meaning 1, 2 is not a solution. And then 1, negative 5, substituting the values of these to the inequality, we have negative 5 is less than or equal to 4 times 1 minus 3. So this is negative 5 is less than or equal to 1. So this is a true statement, which makes 1, negative 5 a solution of the inequality. So verifying whether the point is a solution can be done by substituting the coordinates to the inequality. And if it turns out to be a true statement, then that point is considered as a solution of the inequality. So we will proceed to graphing the inequality. So how do we sketch the graph of a linear inequality? First, we're going to solve for the inequality for y. So for example, in number 1 here, we have y minus 2x is less than negative 3. So we're going to isolate this y and we will convert this into slope-intercept form of inequality. So we can add 2x on both sides of the inequality to eliminate this 2x here. So we only have y is less than 2x minus 3. So we're done with this step. Now, if the inequality includes an equal sign like less than or equal to or greater than or equal to, we're going to use a solid line for the graph of this line. On the other hand, if there is none, it's just less than or greater than, we're going to use a dashed line or a broken line. So like in this case, we're going to make use of a dashed line instead of a solid line. We will do the test point for us to determine which part of the graph has to be shaded. Now, we usually use the origin in testing point because that's the convenient way of doing the process. Involving zero, like multiplying expression to zero, will lead you to zero. So that's the easiest way of doing the test point. But you can assign any point and substitute that to the inequality. So if we're going to use the origin 0, 0 for test point, so we will substitute 0, 0 to the inequality. So we have to substitute 0, 0 to the inequality. So we have 0 minus 2 times 0 is less than negative 3. So this is 0 minus 0. So we have 0 is less than negative 3. It's a false statement. We know that 0 is always greater than any negative integers. Now, 0, 0 should not be part of the shaded region. Now, we're going to convert temporarily this inequality to equation. So, and then we're going to locate 2 points because 2 points determine a line for us to sketch the graph of a line represented by that inequality. So this will be temporarily y equals 2x minus 3. From this equation, we know that the y-intercept is negative 3. So we already have 1 point, and that's 0, negative 3. And to get another point, we'll make use of the slope 2. So this is also the same with 2 over 1. So this is rise over 1. So we will plot 0, negative 3. So this is 0, negative 3. And then the other point can be obtained using the slope. So we will rise by 2 units up, 1, 2, and then run by 1 to the right. So this is the other point. So we're going to connect the 2 points by a dashed line since we are using the less than inequality symbol. So I'll make use of a different color. So we'll be connecting this. And then the shaded region, 0, 0 should not be in the shaded region since we come up with a false statement here. So this should be the shaded region. And this is the graph of this inequality. So first we have to simplify the inequality. Now we have to check what's the inequality being used. Since there is no equal sign here, we're going to make use of a dash line to sketch the line represented by this inequality. And then we will do the test point. Now, we're going to, so since we have made use of 0, 0, and after substituting 0, 0 to the inequality, it turned out to be a false statement, then 0, 0 should not be in the shaded region. So we only shaded this region, wherein 0, 0 is not part of the shaded region. So this is the graph of this inequality. Okay, this time we're going to sketch the graph of another inequality. So let us solve for the inequality. And then we have 2x minus 3y is greater than or equal to 12. So we will add negative 2x on both sides of the inequality. So we have negative 3y is greater than or equal to negative 2x plus 12. So we will divide both sides of the inequality by negative 3 and then simplify. Since we are dividing a negative expression on both sides of the inequality class, we are required to reverse the inequality. So from greater than or equal to, this becomes less than or equal to, and then simplify. So this is 2/3 x minus 4. So we're going to do the test point. We can make use of this inequality or this. Either will be considered correct. Now, substitute 0, 0 to the inequality. And then we have 0 is less than or equal to 2/3 times 0 minus 4. So we have 0 is less than negative 4. And it's a false statement. Again, 0 is always greater than any negative integers. So what we're going to do is temporarily convert this to equation. So this would become y equals 2/3 x minus 4. And from here, we know that we already have 1 point, which is 0, negative 4. The other point can be obtained using the slope m equals 2/3. So from 0, negative 4, from here, we're going to move up by 2 and then run by 3 to the right. 1, 2, 1, 2, 3. So this is the other point. And then we're going to connect the 2 points. This time, class, we're going to make use of a solid line since there is an equality symbol. Okay? So we will connect the two. Okay? Let's assume that this one, this one, and then this should be the shaded region since we come up with a false statement when we substitute 0, 0 to the inequality. So 0, 0 should not be part of the inequality. So how about this one? So we're going to simplify the inequality. 4x plus 2y is greater than or equal to negative 6. So we have 2y is greater than or equal to negative 4x minus 6. And then divide both sides by 2. So we have y is greater than or equal to negative 2x minus 3. And then we will do the test point, and we're going to use 0, 0. And then we will substitute this 0, 0 to this inequality. So we have 0 is greater than or equal to negative 2 times 0 minus 3. So we have 0 is greater than or equal to negative 3. This time, this is a true statement. So 0, 0 should be in the shaded region. And then again, temporarily, we will replace greater than or equal to symbol to equality. So we have minus 2x minus 3. And we already have 1 point since this is the y-intercept. So we're going to make use of 0, negative 3. And we're going to consider negative 2 or negative 2 over 1 to find for another point. So from 0, negative 3 here, we're going to move down by 2 units and then run by 1 unit here. Okay? So, again, so from here, we use the test point. We substitute 0, 0 to the inequality. So, we have 0 here greater than or equal to the negative 2 times 0 minus 3. So, we got, this is 0. So, we have negative 3 here. And then 0 is greater than or equal to negative 3. So, we got this true statement. And then temporarily, we change this to equality to assign 2 points because 2 points determine a line. Since this is in slope-intercept form, the constant term is the y-intercept and the coordinate for that is 0, negative 3. We located for another point by considering the slope. So from the y-intercept, we counted or we moved down by 2 units and then we run by 1 unit as described by the slope. And then we will connect the 2 points using a solid line since the inequality has an equal symbol. Okay? So we will connect the 2 points. And let's use a darker color for that. There. There. And then 0, 0 is part of the solution. So I hope you were able to understand how to sketch the graph of linear inequalities in two variables.